On the grand stage of the cosmos, few theories provoke as much curiosity as quantum physics. A term that seems to be plucked straight from the realms of science fiction, quantum physics is the study of the very small, the particles that make up everything around us, from the smallest speck of dust to the vast expanse of the cosmos. At its heart, quantum physics is about understanding the fundamental building blocks of our universe. It's the study of particles smaller than atoms, particles that behave in ways that defy our everyday logic. It's a domain where particles can exist in two places at once, where they can be both particles and waves, and where observing a particle changes its state. Quantum physics has radically transformed our perspective of reality. It has forced us to reconsider our understanding of the world and of ourselves. It has challenged our intuitive grasp of the nature of existence, pushing us to accept that at the most fundamental level, our universe is not made up of solid, discrete objects, but of probabilities and uncertainties. This science has not only revolutionized our theoretical understanding of the universe, but it has also had profound practical implications. It underpins much of modern technology, from the microchips in our computers to the lasers in our DVD players, from the atomic clocks that keep our time to the MRI machines that peek inside our bodies. Quantum physics is the key that has unlocked many of the universe's most profound mysteries. It has been our guide as we've ventured into the subatomic world, a world that is as fascinating as it is bewildering. It has shown us a reality far removed from our everyday experiences, a reality that is much stranger and much more intriguing than anything we could have imagined. So, why does quantum physics matter? It matters because it's the foundation of our understanding of the universe. It's the lens through which we view the cosmos, the framework that guides our exploration of the physical world. It's the science that has redefined our concept of reality, that has shown us that the universe is far more mysterious and far more magnificent than we ever thought possible. Now, journey with me as we delve into the timeline of this awe-inspiring discovery. Our journey starts in the late 19th century with Max Planck, the father of quantum theory. This German physicist was grappling with a problem known as black body radiation. Traditional physics couldn't explain why objects, when heated, emitted radiation in a particular pattern. The pattern was a mystery, a puzzle piece that didn't fit into the established scientific understanding of the time. Planck, ever the persistent scientist, wasn't about to let this mystery slide. After years of deep thought and countless calculations, he proposed a radical solution. He suggested that energy, instead of flowing in a continuous stream, was actually delivered in discrete packets. These packets he called quanta, and they were a game changer for the world of physics. This idea was revolutionary. It contradicted the long-standing wave theory of light, which was part of classical physics. But it wasn't just a thought experiment. Planck had a number to back up his theory, a new constant of nature that came to be known as Planck's constant. Planck's constant, represented by the letter h, is a very small number, but its implications are enormous. It's the size of the smallest possible packet of energy, the quantum of action, and it's at the heart of the quantum world. It's a bridge between the world we can see and the strange, fascinating world of the quantum. The introduction of this quantum of action was nothing less than groundbreaking. It was like opening a door that had been locked for centuries, revealing a new universe of possibilities. But at first it was met with skepticism. After all, it was a drastic departure from the comfortable, predictable world of classical physics. But Planck was undeterred. He believed in his theory, stood by his constant, and continued his work. And as more and more evidence piled up supporting his theory, the scientific community slowly began to accept this new quantum reality. Little did Planck know, his discovery would set the stage for a scientific revolution. A revolution that would transform our understanding of the universe and pave the way for technologies that define our modern world. But that's a story for another scene. Stay tuned. In the early 20th century, the quantum revolution had begun, with Albert Einstein leading the charge. The man known for his wild hair and piercing gaze was about to shake the foundations of physics. Einstein's pioneering work started with what seemed like a simple experiment, the study of the photoelectric effect. This phenomenon, where light causes certain materials to emit electrons, was quite puzzling to scientists of the time. The classical wave theory of light couldn't explain why the energy of the emitted electrons depended on the color or frequency of the light, not its intensity. Enter Einstein with a revolutionary proposal. He suggested that light, previously thought to be a continuous wave, was actually made up of discrete packets of energy. He called these packets quanta, or what we now know as photons. This was a radical idea at the time. Light as particles? It was a bold departure from the established wave theory of light. Many scientists were skeptical, even dismissive, but Einstein was not deterred. He believed in his theory, and he set out to prove it, and prove it he did. With meticulous experiments and calculations, Einstein demonstrated that his theory of light as particles could explain the photoelectric effect. The energy of the emitted electrons did indeed depend on the frequency of light, exactly as his theory predicted. This groundbreaking work won Einstein the Nobel Prize in Physics in 1921. But more than that, it marked a turning point in our understanding of the physical world. The quantum revolution had truly begun, but Einstein's work was just the beginning. His theory of light as particles opened up a whole new world of possibilities. It paved the way for the development of quantum mechanics, a theory that would transform our understanding of the universe. Einstein's work opened the door to a new world of quantum possibilities. His quantum revolution continues to this day, shaping our world in ways that Einstein himself could scarcely have imagined. Enter Werner Heisenberg, a man whose name became synonymous with uncertainty. A brilliant physicist, Heisenberg put forth a notion that would forever alter our understanding of the universe. This was the uncertainty principle, a cornerstone of quantum mechanics. The uncertainty principle states that you can't accurately know both the position and velocity of a particle at the same time. The more precisely you try to measure one, the less precisely you can know the other. It's as if the universe itself is telling us that there are limits to what we can know. This was a radical departure from the deterministic view of physics, where if we knew the initial conditions of a system, we could predict its future. The uncertainty principle introduced the concept of probability into physics. It suggested that the world at its most fundamental level is a game of chance, not certainty. Imagine you're trying to take a picture of a bee buzzing around. If you use a fast shutter speed, you can capture the bee's position clearly, but you won't be able to tell how fast it's moving or where it's headed. Conversely, if you use a slow shutter speed, you'll see a blur that shows the bee's motion, but you won't be able to pinpoint its exact location. That's a simple analogy for the uncertainty principle. This principle had profound implications. It wasn't just about small particles, it was about the nature of reality itself. It suggested that the universe is not just a giant clockwork mechanism ticking away with absolute precision. Instead, it's a dance of particles constantly in motion, their movements dictated by probability, not certainty. Heisenberg's uncertainty principle was a bold leap into the unknown. It challenged long-held beliefs and opened up a whole new realm of possibilities. It was a turning point in the story of quantum physics, a shift from a world of absolutes to a world of probabilities. Heisenberg's uncertainty principle was the final piece in the quantum puzzle. With the principles of quantum physics in place, we had entered the quantum age. This was an era, not just of scientific discovery, but of technological revolution. Quantum physics, with its strange and counterintuitive properties, has had a profound impact on the technology we use every day. It is the invisible hand guiding the inner workings of our modern world, and it's been instrumental in pushing the boundaries of what we thought was possible. Consider the humble computer, the binary system that forms the backbone of all modern computing is a direct application of quantum mechanics. Quantum physics allows us to manipulate individual atoms and particles, heralding the advent of quantum computing. These quantum computers, leveraging the principles of superposition and entanglement, promise to solve problems that are currently beyond the reach of classical computers. Then there are lasers, devices that have become so commonplace in our lives that we hardly give them a second thought. But lasers are a direct application of quantum physics, harnessing the power of light at a quantum level to cut, measure, and communicate. Whether it's in a supermarket barcode scanner, a high-speed fiber optic network, or a surgical procedure, lasers are an integral part of our daily lives. Quantum physics also plays a crucial role in medical technology. Magnetic resonance imaging, or MRI, relies on the principles of quantum physics to provide detailed images of the human body. This technology has revolutionized healthcare, offering a non-invasive way to observe the inner workings of the body and diagnose a multitude of conditions. Even as we speak, quantum physics continues to inspire new scientific and technological breakthroughs. It's driving advancements in fields as diverse as cryptography, telecommunications, and renewable energy. The quantum age is not just about understanding the universe on a fundamental level. It's about using that knowledge to improve our lives. Quantum physics, once a theory shrouded in mystery, has become the foundation of our technological world. It's a testament to the power of human curiosity and our relentless pursuit of knowledge. The quantum age is here, and it's shaping our future in ways we can barely imagine. Today, we stand on the frontier of the quantum world, peering into the unknown. Our journey through the realms of quantum physics has brought us here, the quantum frontier. It's a wild, uncharted territory, where scientists are making astonishing discoveries that push the boundaries of our understanding of the universe. Let's delve into the fascinating world of quantum computing, one of the most exciting areas of ongoing research. In traditional computing, information is stored in bits, which are either 1 or 0. Quantum computers, on the other hand, use quantum bits or qubits. A qubit can be both 1 and 0 at the same time, thanks to a quantum quirk known as superposition. This means that quantum computers could potentially solve complex problems much faster than classical computers. But here's where it gets even more mind-bending. Ever heard of quantum teleportation? It sounds like something out of a science fiction novel, doesn't it? But it's a real concept in the quantum world. Quantum teleportation involves transferring the state of a quantum particle to another distant particle without physical movement. Scientists have already succeeded in teleporting photons, and the potential implications of this technology are staggering. Imagine a future where information could be transmitted instantaneously across vast distances, bypassing the limitations of speed and space. Or consider the potential for ultra-secure communications, as any attempt to intercept a quantum message would disrupt the delicate quantum state and reveal the intrusion. As we explore the quantum frontier, it's clear that we're not simply uncovering new scientific facts. We're reshaping our understanding of reality itself. The quantum world is strange and counterintuitive, but it's also full of limitless potential. The future of quantum physics is brimming with exciting possibilities. From revolutionizing computing and communications to unlocking new ways of understanding the universe, the quantum frontier is a realm of untapped potential. As we continue to unravel the quantum mystery, who knows what secrets the universe has yet to reveal?